So we're looking at the index laws for multiplying and dividing. So essentially, the law for multiplying says that when we have one power multiplied by another, where the bases are the same. So remember, the base is the large number that's written, or the pronumeral. We add our indices, so our powers, together. So if you've got, say, for example, a to the power of m multiplied by a to the power of n, in its simplest form, we write that as a to the power of m plus n. Similarly, with our law for dividing, when we've got a to the power of m divided by a to the power of n, take note, our bases are the same. Okay, now usually in all algebra, we don't really like to write division symbols. We'll write that as a fraction, okay, and I'm going to show you why in a little bit. So once we've written it as a fraction, we are subtracting our powers. So a to the power of m divided by a to the power of n gives us a to the power of m minus n. Now, I get that it looks a little bit confusing when it's just written like that with no context whatsoever. So I want to show you how this actually works and why they are our laws. Okay, so hopefully it will make sense after that. So we'll look at multiplying first. So we've got 3 to the power of 5 multiplied by 3 squared, or 3 to the power of 2. So if I wrote those in expanded form, I've got 3 times 3 times 3 times 3 times 3, 1, 2, 3, 4, 5, that's 3 to the power of 5. Then I'm multiplying that by 3 squared, which is 3 times 3, isn't it? So once we've got it written out in expanded form, we can actually see that we now have 3 to the power of 1, 2, 3, 4, 5, 6, 7. Okay, and to save us having to write that out like that all the time, we can see, well, 3 to the power of 7, we had 3 to the power of 5 multiplied by 3 to the power of 2. Of course, 5 plus 2 gives us 7. Okay, the law still applies when we have different bases. It just means that we only add the powers of the same base. So our bases will stay separate. So if we've got x to the power of 3, y to the power of 4 multiplied by x squared y, okay, we treat them separately. So x to the power of 3 times x squared, or x to the power of 2, is x to the power of 5, because 3 plus 2 is 5. Now, y to the power of 4 times y to the power of 1. Sorry, y. So y means y to the power of 1. Okay, because when you write it out in, I guess, expanded form, it simply looks like that, doesn't it? So 4 plus 1 gives us 5. So it becomes x to the power of 5, y to the power of 5. So our simplest form is not to have any multiplication symbols in there. Okay, so you do need to remember, when there's no power, it's like it's a power of 1. All right, so a little bit more multiplication before we move on to the divisions, because I just want to show you, this is something you need to be really, really careful of. Okay, so we have 3m to the power of 4 multiplied by 2m to the power of 5. Over in this term, only m is being put to the power of 4. The 3 has no power. Okay, and similarly over here, it's just the m that's being put to the power of 5. The 2 has no power. So because the 3 and the 2 have no powers, we will just multiply those as normal, because they're not bases. It's just 3 times 2. So of course 3 times 2 is going to be 6. M to the power of 4 times m to the power of 5. Well, of course, 4 plus 5 gives us 9. All right. So 3m to the power of 4 multiplied by 2m to the power of 5 gives us 6m to the power of 9. And then I want to show you division, and of course I had to use a power of 10, but I want to show you why this works. Okay, so I've got x times x times x. I won't say them all because that will be annoying. One, two, three, four, five, 6. That's x to the power of 10 there, written in expanded form. Now, I just want to take a second to show you, this is exactly why we write algebraic x's as like the 2 curls. Okay, so that if you ever do get expanded form like this, you can tell the difference between the multiplication symbols and the x's. Okay, and of course we're writing in a fraction. That's a long fraction line, and x squared is x times x. Okay, so what happens here? Because it's just multiplication and division, we can actually simplify. So of course x divided by x is 1. Anything divided by itself is 1. 5 divided by 5, 1. 8 divided by 8, 1. 641 divided by 641 gives us 1. So of course x divided by x gives us 1. So once we put 1 in that fraction, it becomes invisible, right? And I'm going to cross this one out as well. So that's all my x's gone off the bottom now. So when I count up how many I've got left on the top, 1, 2, 3, 4, 5, 6, 7, 8. So it gives us x to the power of 8, which brings us back to our law that when we are dividing, we subtract our powers, because of course 10 minus 2 gives us 8. Okay, then we start to get a little bit more complex with our dividing law, but we still are using our dividing law. Okay, check what has powers and what does not have powers. 8 does not have powers, 12 does not have powers, so we can divide them as normal. But 8 doesn't divide by 12. So this is exactly why we write these as a fraction, okay? Because 8 over 12 we can't divide, but we can simplify, okay? So you have a think, what's the highest common factor of 8 and 12? That, of course, is 4. So when we divide both 8 and 12 by 4, 8 becomes 2 and 12 becomes 3. Okay? Then we can use our laws as normal. 6 minus 2 becomes 4. 3 minus 2 becomes 1. So we'll write that out. And it can be handy to, I like to cross them out as I'm going. So what I'm really doing here is I've got rid of my a squared and I've taken those 2 off the 6 and given it 4. I've got rid of my b squared, taken those 2 from the 3 and made it 1. Okay, I've just written the 1 there because this is kind of my working out, and then I'm going to write my final answer over here. So I've got 2a to the power of 4 on the top, b, because b to the power of 1 is just b, over, have a look what's left on the bottom, it is just 3, because the a squared is gone, the b squared is gone. Alright, so it's about looking really carefully about what you can do. Then, lastly, this is about as complex as these 2 laws are going to get for you guys. But we need to make sure we understand what's going on when we need to combine our laws. Okay, so on the top here we've got 2a cubed b multiplied by 8a squared b cubed all over 4a to the power of 4 b squared. Okay, so we actually have a multiplication up the top and then we have a fraction or a division to do. So what we're going to do is we're going to simplify just the numerator first. Okay, my 2 doesn't have a power, my 8 doesn't have a power. So 2 times 8 gives me 16. Okay. A to the power of 3 multiplied by a to the power of 2. We add our powers, that becomes a to the power of 5. B, of course, that's b to the power of 1 multiplied by b to the power of 3. We add those powers, that becomes b to the power of 4. Over, now there's nothing to simplify in the bottom, it's simply 4a to the power of 4b to the power of 2. Okay, now we can use our division law. Alright, so 16 divided by 4, that actually does divide by 4, and it becomes 4, right? So our 4 stays on the top, because if you were looking at it as simplifying common factors, the highest common factor of 16 and 4 is actually 4. So 4 goes into 4 one time, 4 goes into 16 4 times. Alright, that's why our 4 stays on the top. Okay, and then we have a to the power of 5 over a to the power of 4. Of course, 5 minus 4 gives us 1, so those 4 go, that becomes 1, which is just going to leave us with an a on the top. B to the power of 4 over b to the power of 2. 4 minus 2 is 2. They go, that becomes a 2. Okay, So they are our index laws for multiplying and dividing. Okay, seemingly simple, but there are a few places where you can get stuck. Notably, I would say here people tend to think that the 3 has been put to the power of 4 as well, and that can be confusing. And also down here where we need to combine our laws, okay, just make sure you do any simplification on the top and or the bottom before you do the division. All right, hopefully that was really helpful. Give us a thumbs up if you were able to get something from that. If there's anything else you would like me to cover, comment below and I'll do my best. And if you subscribe to my channel, you'll get notified when I upload new videos.